in the previous video, we got the possible moves from each type of piece. So pawn, knight, bishop, rook, queen, and king. And all of these possible moves, they will be here into this array. Now, to continue a refactor, what we need to do is to convert these possible moves into the valid moves. For that, we're going to use the functions which we already have, get valid moves for row and column, and checked valid move. But we need to change a bit their signature here, the parameters they receive, to instead of receiving this specific stuff, they need to receive our new interface that we created, the possible move. Let's bring this here then. I'm going to remove all of this and just say here move or possible move. Let's call it possible move. This type of possible move. The same here for our valid moves row and column. Say possible move of the possible move. And this now is part of inside our function. I'm just going to bring it here. Const all of this from the possible move dot the row column config. And all of these informations here can be used in the continuation of this function. However, we see that there are some issues here. It may not exist in this row column valid move check or undefined, because this can potentially be undefined in case we're calling this whenever we're just maybe checking for a valid move. We did that wrongly, let's say. So let's bring this inside an if. Or we just check if there is not the row column config, return. Here, in this case, we're going to return an empty array. And now everything that comes after it, of course, is validated, so we're sure to have it. And the errors disappear. We still have this error here of the new move because we're using the function now, the check valid move, but we changed here how this function works. So let's first fix this one up, and then we come back there to fix that one. The possible move, again, it will have to check if not a possible move dot single config. So if there is not this, we're going to return this move check. Let's get it here now, directly return the move check. Just so we don't check anything else, we just break directly. And the rest of the information we can destructure just like we did in the valid moves for row and column. We're going to say here the target coordinate. We also need the block if opposite color and block if empty from our possible move dot single config. Now this can be all done here, all checked, and this should verify check is inside the possible move. So possible move block check verify. Here then, as we did in the negation, we're going to just put in not in the front. So in case it's not meant to be blocked and is in check. So this will only be executed. This will only be executed if this is true, right? Because if this is false, the right side of this if will not be even executed. JavaScript will not even run it. So we are sure that this is in check function will only be called if this is false. Now, in our get valid moves for row and column, we do have this new move here, which needs to be sent to check. Here we have this new move, it's a move model. How do we transform the move model to this possible move, like we did for the whole other types of pieces? We're just going to change slightly what we need to do. And here in this new move, I'm going to say in here, new possible move, just to be quite sure of what we're doing. We'll say then possible move and single config. The single config will be target coordinate with the row and the column. And what else? This type, it will be here inside. Yeah, this one. I think I'm missing one. This is move type. No, not type anymore. Of normal. This new possible move, let's update the row and the column inside the target coordinate. Like this. No, single config. Sorry, single config dot target coordinate dot row is that one. And now we're going to send this here. Of course, TypeScript cannot understand that this single config is not undefined, even if we just created it here. So let's shift this logic a bit, and I'm going to say const possible column. It will be column increment. And then I'm going to do a ternary if. If this column increment is true, I'm going to edit this one, the logic that we had before. Otherwise, just column. I'm going to do the same for the row. So possible row is row increment. If so, this one. Otherwise, this other one. With this, I can remove these two ifs and add the possible column here and the possible row here, like so. Now we check this valid move. So for a possible move, verify that everything else, I think it stays the same. Also going to validate that, right? Here, all seems to be in place. I'm not going to uncomment this yet. I don't want to cause even more refactoring or more changes than I already did since last time we ran this project. But to finish this up, we're going to check for all these possible moves and transform them in our array. For that, let's create maybe a map. Let's say here valid moves equal possible moves dot map. Let's say here move of type. Here's possible move, simple as that. And we're going to check if move dot single config. We're going to return. What is the name of the method? Check valid move. Return check valid move, sending in the board, the square, it's like we had before, and of course the move. If move dot row column config, return name of the method, add valid moves for row and column, like so. Here then we have board, square, and move. This, however, will cause a small problem because the valid moves, it will be an array of move check, if I'm not mistaken. Double check. Yes, move model. Model. But the return of this function here is an array per se, right? So this is an array, move model, and then here is move check only. So this is a move check, this is a move model. We need to, we have two different returns. So we need to validate both of them. Let's change up our logic a bit then. And I'm going to create here then these valid moves as a single array, simple like this, which needs to be of move model in the end, because it's what we really need, not just the move check. And this move inside the move check is the move model that we need. So we're just going to grab it whenever we are in a single config. Now, instead of using a map, I'm going to say a for each. And I'm going to say valid moves dot push, in this case here, check valid move dot move. This could potentially be no. So we're going just to adjust this to accept no's as well. And now, if there is the row column, valid moves dot push, and I'm going to add all of these ones. So let me structure this, and now we're adding all these elements from the result of this one. Slightly different logic, but still the same idea. With the possible moves, the valid moves field, given our possible moves, we can remove this, and uncomment this part. We're going to check if there is move, just to remove all these nodes here, and then does the check that we were doing before to see if these moves are not out of the board. And this would be our get valid moves final. With the idea here, let's run our project and see if there is, not if there is, but how many errors we have and fix them one by one. Open here the terminal, npm run dev. Okay, it ran. That's weird. Here's our board, filled in, console. Just the favicon icon. I'm impressed. If I say I'm impressed, if I select the pawn, I can move. actually, it works out of the box. Well, if you're a developer, you know this is not normal. So it seems it works. Unless otherwise stated, our logic is perfect and working as it should. What we need to do now is to get this all valid moves for player and push this here, like this validation here. But in the possible move, we're going to set this to true in order to prevent our application from going crazy, going on an infinite loop. For this, I'm going to this get valid moves function here, which will add another parameter, which will be block checks, check verify, like this. It should be a boolean, and by default, this is false, right? So we don't want to have, I can remove then this because then it's of course a boolean by default. And for all of this here, all this movement here, we're going to create a change slightly. We're going to say that the move dot block check verify equals this block check verify before sending this down to the rest of our validations. And now with this in place, we can just come up here and comment. I think here's not a null anymore. We can set undefined. And now here we say true, block all the checks. If our logic is correct, we should then always block this here because, yeah, of course, we're allowing this. And with this refactor we did across these two big videos, especially the previous one, we prevented this block check verify from going all across our application, traveling to the piece, to the port, to the game, and whatsoever, until it comes back to the move validation service. Like so, it's here, it's beside the move validation service, and it just keeps here. All this logic about blocking the checks in order to validate the moves should not be responsibility of the other components, of the other models, but of our move validation service. And here you can see how it would work. Run your application, going to refresh and see if it still works as normal as before. What I want to try to do now is I'm going to open here and put this bishop. Yeah, now I have the error. Okay, range maximum call stack size exceeded. We still have a loop, so we need to verify here what went on because probably our logic here is not perfect. First thing I'm going to do, I'm going to say here new move. And I'm going to say move this structure to lose the reference in this one and add this property like so. Now I'm going to grab this new move and add it, send it down the line. Let me refresh, clean up the errors in the console, open here with the pawn, open with this pawn. Okay, the error continues, that's fine, but just now we lose the reference and we don't change the parameter here of this function, which is better not to do in any case. We still have, okay, board component, here, move piece, of course, we see that move relation service in the for each, this is getting an infinite loop. And of course, you see here, maximum call stack size exceeded. But it should not be arriving here, as this should have been blocking all this verification. So we'll probably have, let's see if we can put in our move relation service. Let me close the others. Close others. And now add in here this one, a breakpoint. Refresh. Select the pawn. Open up a bit better here. Block of opposite color, block if empty. That is fine. We have the possible move. Block check verify false. Okay, that's fine because we're just checking for the movement of the pawn. This is all the possible moves. Okay, it's a lot of moves possible. Let me remove here so we can continue. Now go to the pawn, and I'm going to edit. If I select the bishop, we see here possible move. Let me open this a bit more. single config. So it's checking for one movement specifically, which is move type normal, target coordinates. And oh, okay, I know where is the problem. I already see the problem. See that the possible move has not the should block the check. And this is interesting. This is interesting. Let's remove this breakpoint. I'm going to open this a bit more. And why did it happen? In our check valid moves for row and column, we are creating a new possible move, but in here I completely forgot to add the configuration here for the block check verify. And this block check verify should be specified by the possible move that we are adding. So here, this could be what is complaining about, does not exist. Move check, it's not a possible move. It's possible move. We clearly have here some naming issues because yes, this is the possible move. And then this one is the new possible move. And then check valid move. I'm going to rename this to checked move, like so. And now, okay, it doesn't complain with that anymore. And this possible move is the one coming from here. With this, now our get valid moves from one column should be better. Let's check it out again. Refresh. If I select the pawn, select the other pawn, select the bishop. Okay, can navigate fine. And if I select now this knight, there is no possible moves for the knight, but it should be able to come here. So that's a problem. If I select the pawn, it should be able to come here, the queen here. So we see that we are validating our checks because we're not allowing the black to make unnecessary moves that don't put it in check, but we're also not allowing the ones that would prevent the check, as we see here. So white bishop is targeting this square here to the king. We need to validate then why our logic is not working for the checks itself, but the validation here, check valid moves for one column and the check valid move, they are coming to these other functions and making the validations wrongly, but they are doing it. If you know where they are, please tell me, because we need to dig a bit here and to understand what's going on. I'm not going to debug directly on Chrome because as there's a lot of moves being validated, it will just be completely unpractical to do it there. Okay, to be just too many times checking the same breakpoint. I'll just validate then. Start here for the get valid moves. I don't see much that can go wrong here. We grab the possible moves for each of the moves. We go, we add, we should check, block the check verify, which is working fine because our infinite loop is gone. If it's a single config, we're going to check the valid move. Otherwise, we check the valid moves for row and column. Row and column, validate, start, grab the information, and run a for. Okay. This for, get the count, how many go, possible columns, possible row, everything fine here, no, not much problem. New possible move, seems fine to me. And then if this checked move, if there is a move, you add it. It should break because there is another piece in front of it, then we break. Okay, you stop the for. Nice. Let's then check the valid move. If there is not validation, grab the configuration, information we need, target square. If there is a piece, we verify if this piece is already fine, like verify if the piece is of different color. If it's not blocked, it's mostly done for the pawn. And then we say if it gives check, if the piece that we are targeting is a king, which is good, it's fair. So we say that it gives check, but doesn't mean that we're actually validating it, right? We just confirm, okay, gives check. If the piece would be here, it would give a check. Then here it should break because in case, yeah, for the valid moves row and column, if the block's not empty, then you can just do this move normally. Okay, that seems fine. If should not block check, which is working, otherwise our loop would be infinite. And if is in check, sending the board, the square, I will rename this is in check to would be in check. It's a bit more appropriate name for this function. So it would it be in check if the board and in this square did this move here, this move here. So if there's no move, just don't return anything. Create a new board, move the piece, square, put in, grab the piece from this square to this square. Okay, this move not being used now, if I'm not mistaken here. Yeah, not being used. You see here that the move model, because we still didn't reallow this, we're going to do that later. Const open valid moves, get all valid moves for players, sending the board. No, sending the new board. Need to validate the moves for the opposite player, but not on the board as is, but in the board as it would be with this move here. So that's what we want to check. Let me refresh here and see if now our function is working. I'm going to put our bishop here, and perfect. This pawn can now block the bishop. Let me do some more movements. Maybe if I do this one here, and if I try to take the knight, oh yeah, it's fine because that's my queen. I could allow. Let me maybe add this one here. Bring the knight. I'm going to open here my king just to check. My queen, the bishop, and now maybe just move this bishop back and bring this bishop here. So now, what could be possible here? I could block with my queen. That's good. I could run away with my king. We cannot castle for check, but that's probably we'll see later on. But we could move the king, perfect. And technically, we can capture the bishop. That's all the possible moves, perfect. It's working as intended. It's exactly what we needed. It was just missing indeed here, sending the correct board, not the old board, but the new board. And with this, we have our game now validating the checks. What we need to do next, and this will be then for our next video, is to reallow our special movements, of course, and start looking for checkmates. But this is not for this video, as I said, it's for the next one, and I'll see you there.